Good afternoon, everyone. My name is Eleanor Harvey. I am the senior curator at the Smithsonian American Art Museum and curator of the exhibition Alexander von Humboldt and the United States, Art, Nature, and Culture. It is my great pleasure to welcome you to another of our lectures on the world of Alexander von Humboldt. Our speaker this week, you're in for a real treat, is Tom Lovejoy, who is an award-winning and internationally recognized conservation biologist. In fact, he coined the term biological diversity, which entered the lexicon in 1980. He holds both an undergraduate degree and his PhD in biology from Yale University. And in the 1980s, he brought international attention to the world's tropical rainforests, in particular, the Brazilian Amazon, where he's worked since 1965. With 3 co-edited books, he is credited as the founder of the field of climate change biology. He is also the founder of the TV series Nature, the popular long-term series on public television. He's the founder and president of the nonprofit Amazon Biodiversity Center and the renowned Biological Dynamics of Forest Fragments project. In 2010, he was elected university professor in the Department of Environmental Science and Policy at George Mason University. He currently is also a senior fellow at the United Nations Foundation based here in Washington, D.C. His work has spanned the political spectrum. Tom has served on science and environmental councils under the Reagan, Bush, and Clinton administrations. And at the core of those many influential positions are the ideas which have formed and strengthened the field of conservation biology. I first encountered Tom's work when he was serving as Assistant Secretary for Environmental and External Affairs for the Smithsonian Institution between 1987 and 1998. And in fact, in 1994, he became counselor to the Secretary for Biodiversity and Environmental Affairs. Our friendship took off in 2013 when we both participated in a symposium called Perspectives on Teaming with Nature, which brought together scientists, artists, and conservationists about how nature is both a resource and a partner in all of our work. This is an appropriate springboard for Tom's talk today, Alexander von Humboldt, Polymath of His Time. Tom, I'm going to hand this over to you. I can't wait to hear your talk.
Great. Well, thank you so much, Eleanor, and it's been such a delight to listen to all the lectures in this series. And in a way, for me, this all started in 2009 when the German embassy held a full-day symposium on a Saturday on the 150th anniversary of von Humboldt's death. And it was just a revelation. And at the time, I tried to get some magazine coverage of this extraordinary person and was able to get absolutely nowhere because nothing seemed to be known about him. And then, of course, Andrea did her wonderful book, and you can enjoy her lecture about it in this series. And everything took off and culminates in this extraordinary exhibition. So Charles Darwin met Alexander von Humboldt only once in 1841 and was unable to get a word in edgewise. It was in a crowded room, and von Humboldt never stopped talking for 3 hours. Perhaps that is not surprising for a polymath who was endeavoring to demonstrate how all knowledge was related, and whose first volume in 1845 of 5 on that topic, The Cosmos, was already largely formed in his mind. A summary of the entirety of knowledge had not been attempted since the ancient Greeks. It would not really be attempted again until Everett Wilson's Consilience in 1998. Yet from the very outset, the young Prussians' voracious appetite for knowledge, especially but not restricted, how do I make this go forward? I'm screen sharing, but I want advance.
Try your cursor down in the lower part of your keyboard, the arrows.
Oh, I see it. Thank you very much.
No problem.
So, and I think we just, well, we will go there. Von Humboldt had the kind of mind that is ever hungry for new knowledge, while at the same time examining it as part of an integrated whole, a mind on a perpetual quest for an ever more sophisticated sense of order, and how all of that interrelates. How fortunate it was that he was able to largely escape the role his aristocratic birth would normally have required of him, both for him personally and for the generations who have benefited from his intellectual accomplishments and continue to do so. We are awed by his physical accomplishments, namely climbing higher, 19,000 plus feet, than any other then known human being. But they were always accompanied by measurement, observation, and subsequent analysis. Thus it was, on his daunting voyage to the portion of the Americas controlled by Spain, that he observed how vegetation changed along with the physical environment with increasing altitude. The resulting essay on the geography of plants, published in Spanish in 1809, and finally in English only 2 centuries later, is the true beginning of the science of biogeography, preceding Alfred Russel Wallace and his Geographical Distribution of Animals of 1876 by almost a lifetime. Von Humboldt's tremendous understanding of physical and biological nature predisposed him to understand the negative impacts of human activity on landscapes and the living planet. His acute attention to detail had led him to conclude as early as 1800 that disruption of natural systems for agriculture in Valencia had significantly diminished the amount of water available in Lake Valencia itself. That provided the basis for a general insight into environmental impacts of agricultural systems. He was on the way to the Orinoco, from whence he would glimpse the Amazon, which was under Portuguese dominion and thus not accessible to him. But nonetheless, he saw enough of the Amazon vegetation that he coined a special term for it, the Hylaea, from the Greek. Had he been able to travel further into the Amazon, it is indeed possible, maybe even probable, that he might have imagined the hydrological cycle of the Amazon long before it was demonstrated in the mid-1970s. At that time, a Brazilian scientist, Aeneas Salati, demonstrated that the Amazon literally makes half of its own rainfall internally. Prior to that moment, the prevailing dogma was that vegetation is simply the consequence of climate and has no influence on it whatsoever. Salati's science, based on the oxygen isotopes in rainwater, sampled from the estuary to the Peruvian border, showed unequivocally that the moisture originating from the tropical Atlantic is recycled 5 to 6 times as the air mass moves westward. Approaching the Andes, the air mass rises, cools, and precipitates out the 20% of the world's river water that is the Amazon River system. From early on, much as one feels viscerally when observing the luxuriant, dripping, and misty vegetation of the heart of the Andes by Frederick Edwin Church, it has been clear that trees and leaves are the key to the hydrological cycle. The structure of the vegetation provides complex surfaces for evaporation, and myriad leaves exhale moisture through transpiration. After a rainstorm, plumes of moisture are visible rising from the forest, and the moisture carried by the westward moving air mass provides rainfall further to the west. The question which then loomed in the 1970s and 1980s is one actually quite easily imagined as emanating from von Humboldt himself. How much deforestation would cause the hydrological cycle to degrade to a point of generating insufficient rain for a flourishing rainforest? At that simpler environmental time, almost half a century ago, the tipping point of the hydrological cycle was estimated at 40 to 50% deforestation, with the Amazon equivalent in scale to the 48 contiguous United States. That seemed quite distant. Coal was already in use in the first half of the 19th century, although at a modest scale. But the discovery of the oil seeps in Titusville, Pennsylvania, and the possible value for fuel had barely started at the end of von Humboldt's life. Nonetheless, had he been alive when Arrhenius's 1896 paper was published on the greenhouse effect from natural and unnatural levels of atmospheric CO2, it is clear he would have understood the environmental challenge of climate change. What Arrhenius was actually trying to do in his paper was to explain why the Earth is a habitable temperature for humans and other forms of life. Why wasn't it too cold? And the answer was the greenhouse effect. So the science of climate change is actually very simple and very old. Today, it is clear that we know a fair much more about it. For example, Arrhenius would not have been aware of the variations in temperature over the previous 100,000 years, which we see on the screen now. And in particular, that last 10,000 years in the upper right hand of the graph, a period of really unusual stability for 10,000 years, which includes the rise of agriculture, the rise of human settlements. It basically makes the point that the entire human enterprise is based on the assumption of a stable climate, which of course we are busily changing, and which in the end is affecting not just ourselves directly, but the rest of life on Earth. And this is the most recent of the 3 books on biodiversity and climate change. that I've worked on over the past 30 years. And at this point, one can see there is no place on the planet untouched by climate change biologically. And it also is abundantly clear that a planet that is more than 1.5 degrees warmer than pre-industrial will be a very difficult planet to manage biologically. The impacts of climate change are ubiquitous, not just biologically, but in things like the incredible fires last year in Australia, the ones in the west of the United States this summer. And it's pretty obvious that von Humboldt, with his all-encompassing understanding of the cosmos, with mastery of both the physical and biological sciences, would have understood the potential for a negative synergy between climate change, extensive use of fire, and the deforestation of the Himalaya, the Amazon. Carlos Nobre, South America's leading climate scientist, and I have concluded the negative synergy between fire, climate change, and deforestation has moved that tipping point in the hydrological cycle to 20% deforestation. Among the pieces of evidence is historically unprecedented drought about every 5 years in the Amazon. One can easily imagine von Humboldt and Church speaking out about the imperative to both repair the equilibrium of the Himalaya through reforestation and to back away from human-driven climate change by quickly and drastically revising society's dependence on fossil fuels for energy. That hydrological cycle may be driven by the Amazon, but its influence operates at a continental scale. It is now clear that Amazon moisture contributes not only to maintaining the Amazon, but in addition benefits every country in South America except for Chile, which lies entirely in a rain shadow west of the high Andes. The cycle is, of course, important to Brazilian agriculture, but is also linked tightly to the continental climate system. So von Humboldt was fascinated by the variety of life on Earth and its exploration. And I have this Amazon forest viper, the Bushmaster, on the screen to represent all that variety. And I will explain a bit more about that later. But the variety of life on Earth is an integral part of his work in the cosmos. Consequently, it is easy to imagine how strongly he might feel about the need to address the widespread destruction of other forms of life on Earth, which led to the 2019 projection by the United Nations of 1 billion possible extinctions given current trends. And he would have been among the first to recognize that if we have already driven the extinction rate to 1,000 times normal, that means the odds of a conservation effort being devoted to a species about to wink at normally are 999 to 1. He would not have only understood the intrinsic value of the myriad life forms that constitute life on Earth, but also understood that together they represent an extraordinary library for the life sciences. Each organism constitutes a set of solutions to a particular set of biological challenges. Indeed, individuals of each species are daily experimenting with new solutions to those challenges, which in fact continue to change themselves. Any one of those solutions has the potential to transform the life sciences and bring benefits to hundreds of millions of people and ultimately the entirety of humanity. How, for example, are sharks mostly immune to cancers? How will studies of the saliva of the Gila monster advance understanding and treatment of diabetes? Studies of butterfly genetics led to understanding of the genetics and treatment of Rh-negative babies. And the ACE inhibitors, which hundreds of millions use to manage their hypertension, derives from the biology of this nasty viper from the Amazon and other New World tropical forests. Basically, Brazilian scientists studying how that venom works uncovered an unknown system of regulation of blood pressure, the angiotensin system, and then squib pharmaceutical chemists built the first of the molecules called the ACE inhibitors that hundreds of millions of people use to control their high blood pressure. Imagine if von Humboldt had been present during the run-up to the 1992 Earth Summit itself. He certainly would have been given the keynote of all keynotes. Would we have ended up with 3 different conventions? One on climate change, one on biodiversity, and one on desertification and restoration, or some other construct? To begin with, von Humboldt would have understood that physical science notwithstanding, current human-driven climate change is actually all about biology. All life is built of carbon. The fossil fuels we burn with abandon represent ancient photosynthesis trapped geologically, transformed into natural gas, oil, and coal, which release the energy and carbon in an instant. Climate change is also about the destruction and transformation of nature. Literally half of the carbon in terrestrial nature is now atmospheric carbon. And twice in the history of life on Earth, extremely high CO2 levels from natural causes were brought down to pre-industrial levels by natural processes. But that took tens of millions of years too leisurely a pace to address human-caused climate change. If a third of the current elevated CO2 contributed by terrestrial nature were brought back into living systems through ecosystem restoration, reforestation, but restoring other kinds of ecosystems as well, humanity could reduce the amount of potential climate change to a level far more reasonable than what would be the consequence of current levels of atmospheric CO2. Von Humboldt would have enthusiastically embraced what are termed nature-based solutions, using the biology of the planet to restore biodiversity and capture carbon. In retrospect, there is an argument to be made that having 3 conventions led to a biodiversity convention that spent too much time negotiating access and benefit sharing to the detriment of conservation in its early years, that the climate change convention was left pretty much to physical scientists, most of whom were oblivious to the way the planet works as a linked biological and physical system, and the desertification convention stuck to restoration of degraded lands pretty much out of sight and out of mind. Combined with the failure of the developed countries to deliver on their non-binding promise at Rio to devote a couple % of global GDP to sustainable development, it is not surprising that a consortium of scientists and scientific organizations created an international organization, Future Earth, created to address the scale and accelerating pace of environmental change. One of its first products was an analysis termed Planetary Boundaries. It was essentially a cosmos kind of vision. It has as its heart, it is at its heart Humboldtian, essentially a spider web, which at its center shows the green, safe, and historical operating space for humanity, and radiating out its various segments or slices, showing how far collectively humanity has transgressed beyond those boundaries in climate change, atmospheric carbon, nitrogen use, phosphorus, biodiversity endangerment and loss, plus potentially others that remain to be measured. You will note that biodiversity loss has transgressed the boundaries further than all the others, for the simple reason that all environmental impact factors impact biological systems. The planetary boundaries have not been without criticism. There are people and governments resistant in some cases and in others oblivious to limits. They have a gut reaction against the notion of limits, but these limits are scientific, not political. They are best understood as the conditions that gave birth to and nurtured the rise of human civilization. As such, it is inherently unwise to go beyond them as opposed to use our creativity to live within them. The solution is to rephrase the nature-based solutions. The solution is to regreen the emerald planet and bring the carbon back from the atmosphere and bring the temperature down. Aristocrat though he may have been, whoops. Von Humboldt respected knowledge in whatever form he encountered it. He understood the value of the knowledge of the indigenous peoples he encountered in South America, and his aesthetic sense informed his appreciation for nature and living things wherever he encountered them. It is not surprising that he inspired artists and poets, much as watercolors of Yosemite inspired Congress and Lincoln to protect Yosemite as a California state park in 1864. Clearly, von Humboldt fanned the flames of much of America's love for wilderness and nature. Reflecting on von Humboldt and his time, humanity today would be well served if we had a public intellectual of his unparalleled stature, able to speak out and chart the sustainable way forward. While we currently have a lot of cacophony, we would do well to aspire to a Humboldtian vision going forward. Thank you very much.
Tom, thank you. That was really awesome. We have some really terrific questions. Obviously, a lot of them sort of focus on the issues of climate change and the concern that we all have for where we are on the planet. So let me start with one of them, which was really a question about do you think that we have reached or are getting close to a moment where there's a critical mass to address human-induced climate change seriously?
So I think we actually are at a moment of tremendous opportunity because of the serious economic setback from the COVID virus. That actually represents an opportunity to build back an economy that is much more sustainable than the one which is just sort of shrunk dramatically. And you know, there will be a lot of temptation to throw infrastructure and classic solutions at all of this, when we really should be thinking about a major reset that will benefit, you know, human aspirations going forward.
Do you think there's anybody with the stature of a Humboldt today that could be speaking on these issues? Somebody who can cut across, you know, professional disciplines and make that connection?
Well, it's a really serious question, which, preparing for this made me think about. Um, and I think it's much more likely to be somebody who comes out of the world of art first,
Mm-hmm.
rather than out of the world of science, um, because art has such an extraordinary way of cutting across human society. Uh, and we do. I mean, we do see, uh, you know, artists speaking out on this subject, but not sufficiently collectively. I think that's what we need.
Well, I know that when you and I were on the panel at the National Sporting Library and Museum in Middleburg on teaming with wilderness, James Prosek was one of the speakers whose art is clearly deeply concerned with this, as are the works of Mark Dion and Alexis Rockman. Last week we heard from Dario Robledo. Next week we'll have George Steinman, who is really trying to get the UN to tackle the idea that the arts can be a powerful voice to influence the way people respond to the issues of planetary stewardship and climate change. I mean, I'm gratified in thinking that the arts could actually be a powerful voice in order to attract both professional and for the layman among us who are concerned about whether or not we can get traction on this issue. So one of the questions you mentioned, the sort of the idea of a billion possible extinctions, that notion of being on the verge of another mass extinction in the long play of human history. But I'm wondering in part of all of that, whether or not that is something that where the fossil record can be helpful to us. Humboldt was fascinated with fossils. So is there a way that we can be using our knowledge of the past in order to understand our future, to use those lessons from the fossil record to better conserve or manage the ecosystems that we've inherited today?
Well, that's a great question. And it makes me think of wandering around in the Northern Territory of Australia just a few years ago. And all of a sudden, there I was wandering around on a 1.5 billion-year-old seafloor that even had 1.5 billion-year-old ripples of the seafloor frozen in the fossils. And the fossils were entirely of the earliest forms of life on Earth, the blue-green bacteria, the stromatolites.
Wow.
And stromatolites, of course, were the organisms that oxygenated the atmosphere and made possible the subsequent evolution of life, and even an ozone layer, so you could have animals on land and plants on land and have fire, etc. So I thought I would really like to take one of these back as a teaching prop, and I got permission to do so, right?
Wow.
I could begin my first class with, this is 1.5 billion years old.
Oh my God.
And this is the reason we can breathe and exist, right?
That's astounding.
And then, like 3 weeks later, I'm having to prepare some remarks for the 100th anniversary of the Ecological Society of America, and the other penny dropped. Because for the blue-green bacteria, oxygen was a toxic waste substance, and they filled the atmosphere up with it and made themselves scarce.
Oh my goodness.
So there's a lesson.
There is.
Yeah.
There definitely is. Okay, corollary to that. Would Humboldt, do you think, have understood, I mean, we know that he understood the concept of human-induced climate change from his observations at Lake Valencia, and then how he compiled and interpreted the data that he spent the next 50 years amassing. Would he have understood, do you think, the potential for overpopulation being one of the corollary contributors to that?
Well, it's a really good question. And it's hard to imagine that at some point he would not have come to that conclusion.
Yeah.
I mean, the numbers are so different today. I mean, like there are three times as many people alive today as when I was born. You know,
Wow.
and you know, back in von Humboldt's time, the numbers were much more modest. Let's put it that way.
Mm-hmm.
But he was, you know, he was seeing, you know, people spread out across the globe and having impact. So I think he would get it.
Yeah, I mean, I just think about, you know, how Thomas Jefferson was so optimistic that it would take 12 generations to populate the United States from shore to shore following the Louisiana Purchase, and I think it took 3. So, you know, he didn't have the ability to sort of to see that long game there, but my guess is that, you know, Humboldt certainly understood the difference between environmental degradation in large cities as opposed to spread out communities or pockets or even, you know, uninhabited landscapes. But it would have been interesting to bring him forward in order to give him a sense of where the downstream is now and to get his perspective on things. There were a lot of people who asked, if you had dinner with Humboldt, what would you want to ask him?
Wow.
Yeah, that's kind of, where do you start?
Well, you know what I would do? I would ask him what was the most exciting discovery he had ever made. And then I could sit back for 3 hours and listen.
3 hours, probably 3 days.
Yeah.
That would be pretty awesome. So, you know, you gave the title of polymath to Humboldt in the title of your talk, and we have a couple of people who are wondering what talents you think would be essential for a polymath in today's world.
So I actually had my PhD advisor was a polymath, G. Evelyn Hutchinson, who founded modern ecology.
Mm-hmm.
And a polymath is somebody who has no sort of subject limits on what he's interested in.
Mm-hmm.
But it only works if he's got the kind of brain that Hutchinson had and von Humboldt had, to be able to store all that information and find a way to organize it into a system that would make sense. And I remember, you know, watching, probably listening to Hutchinson retrieve one of those bits of information that he had lodged in a particular construct,
Mm-hmm.
and take it out and put it in a different place. I think that's what a polymath does.
That's a really nice description. I like that a lot because it means that the constellation of things that you end up focusing on might shift from person to person, but it's that never ceasing curiosity and wondering how the pieces fit together that leads you to something bigger than what you started out with. And, you know, to me, that's the wonderful thing about Humboldt, with his never stopping talking, with his 36 books, with the sleeping 4 hours a night. It's like the brain never stopped processing possibilities and questions. I remember Edward Everett, who is best known to us as the man who preceded Lincoln at Gettysburg by spending 2.5 hours speaking instead of 2.5 minutes, which is really not fair to him because he was a really smart guy and he inspired Emerson to become a Humboldtian. So we should venerate him for a little bit more than that one gaffe. But Emerson actually calculated the productivity of the normal human being in the middle of the 19th century, and then ran the math on the number of hours that Humboldt spent working, and said he lived 40 years longer than any other human being because he worked that much longer and that much harder every single day.
Wow. So, I mean, it's interesting because, you know, he's famous for continually talking, which means he wasn't necessarily listening for all of that time. but, you know, when the crowds were away and he wasn't asleep, he was absorbing information left and right.
Yeah, we have one question I think is really interesting, that, you know, Humboldt lived in a time of extreme power politics. Certainly his lengthy verbal battles with Napoleon are legendary. And there's a quote attributed to him or one of his colleagues saying that while nations' politics may be in conflict, their sciences should be at peace. And, you know, Humboldt definitely privileged international cooperation and that idea of constantly learning from each other. But what do you think Humboldt would think about, or what do you think about the level of cooperation and collaboration in science and conservation from your perspective and then from Humboldt's?
So my experience has been just a tremendous amount of international collaboration on conservation science and actual conservation, which doesn't mean that everybody always agrees. And that's good because you have different experiments going on and you see what works best in particular locations. You know, what worries me the most is public denigration of science in some countries. And, you know, and those countries are the ones that are really paying the COVID price. I mean, you don't need any more evidence, right?
Yeah, yeah. I mean, I think that's the thing that I think you and I would both say, that in the last few weeks, months, and years, watching the sciences be dismissed at a time when we need to be taking them ever more seriously and integrating them into the way we think, that the process of developing a logical argument, whether it's in philosophy or political science or in the sciences, that we need to be willing to rely on the data, to trust the data, and to find those scientific voices trustworthy is, I think, even more important now, maybe even than it was in Humboldt's age.
Yeah, so I learned a really important word from Daniel Patrick Moynihan, which is comity, the ability to listen to the other side. And I wrote recently that 3 things had changed from what it was like when I grew up. One was a loss of a sense of frugality.
Yeah.
And the second was a loss of a widespread sense of public service. And the third was the loss of comity.
Yeah. Yeah. And you know, it's interesting because one of Humboldt's best friends said that he has the kindest heart and the most slanderous tongue of anyone I'd ever met. And it was rumored that you never left the salons until Humboldt left, because if he watched you leave, you would become the butt of the next joke. But he was also so genuinely delighted to learn from other people and to convey what he knew, that he seems like the kind of raging extrovert who just simply, you know, that is his oxygen, is being in contact with other people. And he often said he did his best work when he was surrounded by people who did better work than he did. And that was a kind of intellectual generosity that a lot of egos that size don't often have. I have a question about the fact that, you know, it's going to take international governmental cooperation to combat the destruction of the planet and its species. And yet we're also battling political expediency and short-term perspectives. Things get postponed. Do you have a sense of how we might learn from Humboldt how to get that kind of cooperation? What could a Humboldt do in order to encourage nations to tackle the hard problems rather than continually punting them down the road?
Well, that's a really great question, because what Humboldt did for knowledge, basically trying to pull it all together and into a logical construct, is exactly what needs to happen in terms of public attitudes about
Yeah.
basically preparing a sustainable future for future generations.
Mhm. I want to build on your comment about comity, because one of the things that we have a question about Humboldt's interdisciplinary background, but that he seemed to embrace knowledge coming from all different quarters. But the people who are working in the now interdisciplinary fields like biogeography and ecology and macroecology, why is it that some of those interdisciplinary fields have a harder time getting traction in the hard sciences?
Well, there is a pecking order in the sciences,
Mm-hmm.
from pure physics and the physical sciences down through geological sciences and biological sciences, and finally, at the tail end, the social sciences. And that's actually not very good for the kind of consilience we actually need.
Yeah. I remember in 1903, Teddy Roosevelt goes on an epic camping trip in Yosemite with John Muir, two Humboldtians trying to figure out how to make sure that Yosemite does not become a reservoir the way Hetch Hetchy would. And Muir says, "How desperately I desire to be a Humboldt," and Roosevelt grouses that the American educational system is no longer training people to do the field work that inspires Humboldts, that all we're doing is training specialists. Do you still think that's what we're doing, or is the pendulum swinging back?
Well, I think that would have been a really tough question to answer in a positive way, like 50 years ago, or 40 years ago, as molecular biology arose triumphant over all other kinds of biology.
Mm.
And it was actually a very arrogant kind of time, which I believe is behind us now. I mean, most universities have even gone back and put together biology departments that include a wider array of things. Others still feel a need to keep the ecological and evolutionary sciences, the
Mhm.
sort of the organismal biology distinct. Um, and you know, I think there's more than one solution to that issue, but they have come back.
Mhm.
In fact, they really use the tools that come out of molecular biology, right? So in the end, it came out with a much better solution.
Yeah. And I think that, what I'm seeing too, and I'm seeing it in some of the smaller liberal arts colleges, is an encouragement of double majors, of majors and double minors or concentrations, and an encouragement of crisscrossing the liberal arts and the sciences. Really, the acronym STEAM instead of STEM, where the arts get inserted into the others so that there's a more holistic and more cross-cutting way of thinking things through. And I know I started in geology and switched to art history, which means, as my colleagues know, I ask weird questions because I'm trained to ask a different kind of question in addition to the standard repertoire for art historians. And so I think that in large part, we look for mentors who will encourage that, who encourage us to cross over those disciplines, to break through the boundaries, to break the rules. And I think that's where the future of liberal arts institutions may rise, is in the ability to create a polymathic way of thinking about the world and putting the pieces together.
So I think, the very distinct rise of environmental humanities is a good example of that. It wasn't there 10 years ago.
Right.
Really.
Yeah. Yeah. I think that's right. Okay, I have to ask this because I've now got 3 questions about it. Everyone wants to know about your house.
Well, I live in the oldest house in McLean, Virginia.
Mhm.
Dates to 1730. And the original house was this room and the adjacent room and a big room down below and a loft above and no plumbing. Now,
Yeah.
it's a little better than that now, but what you can't see on the screen is that it's right next door to a private school with 300 acres of forest. So it's like I get to live in the country and I'm 25 minutes from the mall.
That's nice. All right, we have a question about forests. Back in 1800, when the National Railway was a thing and they were having a hard time getting through Ohio because it was impenetrable because of the thick old growth forests that are out there. Apparently, there's a single grove that exists as kind of its own historic monument. And the person who posed the question wanted to know your thoughts on the impact of cutting down forests across the United States.
Well, there's been a lot of that. I mean, wholesale. Uh, I mean, New England was basically deforested at some point to be agricultural
Mhm.
until people discovered there was better agricultural land to the west, which took down some more forests. Um, so the ability of some of these forests to regenerate is pretty considerable, um, but it varies from forest to forest.
Mhm.
And particularly today, given climate change and the possibility of extensive fire, it's a much tougher, more complicated game.
Yeah. You know, I remember when I was doing the research for this exhibition, when Humboldt visited, Nicholas Collin, who was one of the members of the American Philosophical Society, was already writing in the 1790s about how America's hardwood trees needed to be preserved as monuments, that we could clear cut the valleys for agriculture, but for God's sake, leave the trees on the hills in order to stand for what was there. And in the 1830s, when Prince Maximilian and Karl Bodmer come to the United States to retrace part of Lewis and Clark's route, Max is horrified by how much of Pennsylvania is being clear cut for agriculture. And he is mourning the loss of those old growth forests. So clearly, deforestation was something that was a point of concern, or at least a point of shock, as people either came to the United States or visited the United States. So I'm guessing that the United States must have looked tremendously different as that process is ongoing.
Well, that's certainly true. And, and then the loss of the chestnut tree. And
Right.
I actually have a chestnut tree which grows here, but it doesn't grow very far before the virus gets it. It's almost impossible for us to imagine what those forests were actually like.
Yeah. We know that Humboldt incorporated the knowledge that he learned from indigenous peoples in all of his work about, he was tasting bark, he was tasting water, he was really understanding how quinine comes out of China bark tree, Peruvian bark trees. But are modern climate scientists also making use of indigenous wisdom?
So there's certainly a lot of scientists are very respectful of indigenous wisdom. The specific question you asked about climate scientists, I don't have much experience with, but it's actually impossible not to imagine that people who understand their environment as intimately as most indigenous groups do won't be picking this up.
Yeah. No, I think that's exactly right. And I think that it's up to all of us to exercise that insane curiosity, to expand our boundaries, to ask questions and follow through on them, to make use of the amazing digitized resources that we have, as well as our own family histories and the travel that we've all done, in order to be more thoughtful and more present as we travel from place to place and understand our impact on the world. Tom, thank you so much for doing this. This has been so wonderful, and it's so nice to be able to see you again, even if we, we're so close, but we can't actually be, physically proximate to each other at this moment. And I would encourage all of you, please tune in next week when George Steinman, who is an artist based in Switzerland, will be doing a presentation looking from within, art in the horizon of the UN agenda for 2030. And he is specifically making a plea for the arts to play a significant role in UN initiatives on climate change and planetary stewardship. He'll be presenting one of his own video pieces as part of that, but it's an extraordinary, thoughtful, and moving presentation. For all of you who are here with us, just a reminder that the Smithsonian American Art Museum is one of the nation's nonprofit organizations. We're able to share free digital content with you like this today, thanks to generous supporters like you. We'd like you to please consider showing your support with a donation, and the link for that is just been placed in the chat, so that you can help make sure that we are able to continue doing projects like this, creating content like this, and getting all of you involved. Thank you everyone so much for all of your wonderful questions, and thank you, Tom, for being part of this series.
Well, thank you, and thank you all.